In the previous lecture, we have already shown you that what is the kinematics, what is the difference between the kinematics and kinetics. So today, the new chapter, that is the kinetics of particle. So here, along with the motion of the particle, also we have to consider the force which has been applied on any particle. Okay. So according to the Newton's second law, you all know that a particle will accelerate when it is subjected to a unbalanced force, right? When it is subjected to unbalanced forces, and the kinetics is the study of the relationship between that unbalanced force and the resulting change in the motion. Okay, so you all know, as per second law of Newton regarding motion, that when there is an acceleration, means when we we provide the acceleration on any particle, then it is subjected to any unbalanced forces, right? That due to acceleration of any particle, unbalanced forces are generated, right? So the kinetics is deal with that unbalanced forces and the resulting change in the motion of that particle. Okay. So it is clear that what is the meaning of kinetics of particle. Now there have three general approach to solve any kinetics problem. Okay. So three approach of how to solve, how to how to solve the problem. Okay. Acceleration method. Okay. Any kinetics type of problem we can solve in the three different way. Okay. First one is the direct application of direct application of Newton's second law. Sometime we can call it the force mass acceleration, force mass method. Okay. Another one is use of work and energy principle. Use of work and energy principle. And three is impulse and momentum method. Okay. Now, as per the, you all know, as per the Newton's second law, which is the equation of motion, it is nothing but the Newton's second law is nothing but what? Summation of all forces acted on any particle of mass m and the resultant change in the motion due to that unbalanced forces, which is acceleration, right? So we can write summation of all forces. It means suppose a particle is there and we apply three or four forces, F1, F2, F3. Summation of all forces is nothing but the mass of that particle. of that and the acceleration of that particle. Okay, and we can solve this thing in such a manner that if there is a tension in any particle, we can write this thing in such a manner also. Okay, now another thing is, what is the difference between the constrained and unconstrained motion? Okay, so unconstrained motion means the particle free of mechanical guides and follow a path determined by its initial motion and the force which are applied to it from the external source. For an example, you can say that is the aeroplane. What happened then? Actually, see, in the unconstrained motion, na, in the unconstrained motion, suppose with an example, if we provide, then we can see that if an aeroplane move in the air, then due to its own force which is created by itself, it will change its motion, right? There is a no specific guide mechanical, there is a no specific mechanical guide is there, right? And it follow a specific path. Clear? So this is called the unconstrained motion. And what is the constrained motion? Example of any constrained motion is the train. Suppose a train move on the rail, right? So what happened when it move on the rail? Though it's generate its own force and it will go move forward, but it also have some constraint in that motion, right? And the constraint is here is the rail, right? The rail and the train. So that rail actually guide the train to move forward. So that is called the constraint motion. That is the difference between the constrained and unconstrained motion. Next one is the rectilinear motion. So in the rectilinear, you all know that rectilinear motion, that is the, if we consider a linear movement, and in that linear movement if we apply the force, means we added the force into the system, then we can say that is the force rectilinear force system. Okay, now rectilinear motion, in rectilinear motion, as you all know that for the statically in equilibrium of any system, that should be zero, right? But here, instead of that, as it is a dynamics problem, so instead of that we have to put here the mass of that particle into the acceleration along x-axis, and summation of all forces acted along the y direction is nothing but the mass of that particle and acceleration along y-axis. And if it is a 3D equilibrium, or in case of any 3D particle, then the summation of f of z is equals to mass into acceleration along z direction. Okay, and you all know that this f, if we write in the vector term, it is nothing but the fx of I plus fy of j plus fz of k. And if we put, this is a force vector standard notation, and if we put here all the force, means summation of all forces, right? Then summation of all forces. Okay, so summation of all the forces all forces along b y and summation of all forces along z. So these are the things. So to find out the magnitude, you all know that how to find out the magnitude of force. Then you all know that is the determinant of that force vector, right? This is in a static lecture na? That any uh, force vector is there, then what should be the value? So that is the magnitude and the unit vector, right? You have remembered this thing, right? So f is nothing but the vector divided by unit vector, and unit vector is what? Unit vector is nothing but the determinant of that. So to find out the magnitude is summation of determination of summation of force vector. Okay, as there have a more than one type of force acted on the body, so that's why we have written this here. Otherwise in the static case you already seen that summation of f, sorry, determinant of f is the magnitude, right? Now come to the now come to the curvilinear motion. And in the curvilinear motion, this you know that they have the three types of motion are there na? One is when we consider that is the rectangular coordinate, rectangular coordinate system. Under the rectangular coordinate system, for finding out means to apply the kinetics, means the force on any particle, then we have to do the force along x is nothing but mass into acceleration, and similarly the ax is nothing but the x double dot, means 2 times derivative of the displacement. Similarly it also applicable for y is equal to summation of f of y is equal to m of ay, where ay is nothing but the y double dot, and similarly for z dot. Okay, similarly for, if we consider two, that is one is rectangular coordinate system, one is the normal and tangential coordinate system. So under normal and tangential coordinate system, to find out the force, that is nothing but one is normal. So Fn is mass into acceleration along normal direction, right? Where An is what? Can anyone reply? What is the An? What is the formula for An? Normal component. The acceleration in the normal component. What is the formula for that? Remember anyone or forgot? Last class we have done a numerical problem, and where An is equal to what? An is equal to, you have not written one time, go through this thing. That is the velocity of that particle and the radius of curvature. Na? Remember, this is the radius, and if any car or any particle travel in this path, through this path with a velocity of v, so v squared by rho is the An, right? And the tangential component of force is nothing but mass into At, where At is the derivative of velocity with respect to time. Clear? Now, if another type of problem is there, suppose that is a polar coordinate system used, then what we have to do? we have to simply put polar means radial and normal. So r radial, so radial is m into ar, where ar is what? Ar is r double dot minus r theta dot square, r theta dot square, right? So this is the in case of polar coordinate system. Okay, now another one is the radial, this one, this one is the along the radial component, transverse component. Along the transverse component MA theta, where A theta is what? R theta double dot plus 2r dot theta dot. Na? These two things you have to follow. So up to this, anyone have any query? Up to this, anyone have any query, or should I continue? Please reply at least. My voice is audible, right? If anyone have any question, then you can ask. Or any confusion, any doubt, anything. Any question? Should I continue? If anyone have any confusion, you can ask, because in the next portion, that is the one is direct application, which I had just taught, and then another one is the work and energy. So in work and energy, that is a little bit you have to understand this thing. So before that, this basic idea you have to know. So that's why I'm asking. So anyone have any confusion, you can ask. Otherwise, I shall move forward. Okay, then I shall move forward. Uh, See, the next part is, I told you, three approach we can apply to finding out the force calculation for the kinetics of any particle. So the second one is the work and energy method. Uh, So under work and energy method, first, to start this, before, we have to know what is the definition of work. So can anyone tell me what is the definition of work? What is the meaning of work? Can anyone tell me? Okay, so see, the work means when a force, suppose a force F, which is, suppose this is a particle, and a force F which is acted on a particle, and due to this applied force, that particle move along the path. Okay, if this is the path, for example, we can say, suppose this is the path. Hmm. Through this path, think through this path, this particle will move. Okay, and if it is And if that applied force on that particle applied, then the position vector of that particle measured from some conventional origin, if we say this one, see, suppose they have, this is a curve as you see here, and suppose this one is the radius, and when this particle move along this direction, means in this direction, then consider now new position is this one, that is a dash, consider this one, okay. Then this one take the different radius of r plus dr with an angle of alpha. Hmm. And this distance is nothing but dr. So what happened, when you apply a force on any particle and then it moves along any path, okay, and there have some displacement, so that displacement is associated with this. In this figure you can see a and a dash, this amount of displacement is there. So the magnitude of that is, we can say, that is the work done. So what is the amount of work done? That work done is nothing but the f dot dr, that small amount of displacement due to the applied force. Understand? See, very minutely consider what means, what is the definition of work. If you want to say, then you have to say it in such a manner that if you apply a force F on any particle A, and if that particle move along any circular motion or curvilinear path, so that curvilinear path have a, suppose in this a position have a radius r, and suppose a dash position have a radius of r plus dr, then the amount of displacement it moves, that is nothing but the dr, right? So the dr and the dot product of the applied force is called as a work done, okay. So the magnitude of the dot product is what? Magnitude of dot product means what? F is a vector, right? Dot dr, here dr also a position vector. So if we dot product of two vector, then what we find out, that is magnitude of force ds cos alpha, okay. If means here what is the ds, that is nothing but d mod of dr, okay, that is the magnitude of dr. If you if you draw this in the enlarged form, then you can find out that this is the straight line, and this one is the motion of that particle. If you take a very small portion, for a very small portion, then you can see this one is the f, right? So this one is the f of t, tangential component, and this one is the f of n, means we resolute this resultant force into two component, okay, by using this angle of alpha. So this ft is nothing but f cos alpha, and this fn is nothing but f sin alpha, okay. So if these along this path, means along this, if this is the path, hmm, then the displacement amount is nothing but ds of magnitude is nothing but the vector, the determinant of that vector. So this one is also we can say ds cos alpha, right? This is the enlarged view. So the work du may be interpolated, the work submitted na? I am not submitted after this class. Which one? Hmm? So the work du may be interpreted as the force multiplied by the displacement component. Okay. So what we can write, that is the du is nothing but the tangential component on the force and the ds. This also we can write. Clear? Why it is? Anyone have any idea why it is like that? Why the what is the normal component is going? The normal component actually is not considered to find out the work done. Hmm. Okay. Now see, the work is the positive. For the case, for which case we can consider that work is positive, we can say work is positive if the working component, that is the ft, ft is in the direction of displacement, and negative if it is the opposite to the direction of displacement. Very clear? So the force which do work are termed as a active forces, okay, and constraint force which do not work for termed as a reactive forces. These three or four things you have to remember during the numerical problem. So now how to calculate this work done? See, during a finite movement, okay, let's write this one. See, calculation of work. How to calculate? See, u is the work, you have considered that u is the total work. So u is integration of all forces which acted, and due to that the amount of displacement which occur of that particle. So f is along x, you know fx, so fx dx plus fy dy plus fz dz. Okay, so u is integration of ft dot ds, right? This we can write. So that is the calculation of work. Now work and the curvilinear motion, this is for the rectilinear motion case. These all are the for the rectilinear motion. Okay, now when work come under work and curvilinear motion. Okay, see, here, okay, curvilinear motion, so we have to draw some diagram so that you can easily understand. See, in curvilinear motion means there should have some curvature, right? So if we consider, suppose this one your x coordinate, this one your y coordinate, this one your z coordinate, and if you curvature of path, suppose this pink line shows the path, okay, of that particle which moves, and suppose you have taken radius r, where this one indicates the direction of motion, and the two force means the force which is applied on this is suppose along this direction. So the two component of that force is nothing but, means here you can see this force is nothing but the summation of all forces which acted on that particle. Okay, so you can resolute this force into two component, one is tangential, one is normal. So this is your normal component, this is your normal component, and this is your tangential component, means f t. And the angle which generate between the resultant and the tangent is the alpha, and you consider this particle of mass m. Okay, so up to this is it clear, right? So if this particle move, suppose from this point, we consider this one as a 1, and this one as a 2, then how to find out the amount of work done by that particle? Okay, so to do that, first we have to consider the work done on a particle of mass m which moving along a curved path under the action of summation of all forces, means this result summation of the resultant forces which acted on that particle. So the position of m is specified here by this r, right? This is the position vector, and its displacement along that path during, suppose when the particle at a, means at 1 at the time, suppose the time is 0, and when, consider time is, okay, consider time is t, and when that position that particle comes to another position, consider time is t plus del t. So within del t, means within the time period, it will change its position, right? And it comes to the another point. So what should be the work done by that particle? So as you know that u 1 to 2 is nothing but, sometime before I use that formula na, f into dr, means from position, if we say s1 at one point and s2 the point 2, it is nothing but the tangential into ds, means this is your force vector dot product, and dr is a vector here. Better it, I can write it here like that. So and here these are the ft into ds, this is not a dot product, this is ds, and this s is the magnitude of the change in the displacement, means dr. Dr vector mod of that is ds. Okay, so we can write this thing as ft, the mass into acceleration into dr. Okay, so from this drawing you can see that a means the acceleration of that particle, which is respect to time. If you change, then you can find out that the tangential component into ds, right? So if it is, then we can write that at into ds is the v into dv, right? So we can put, instead of at into s, v into dv. So u of 1 to is integration of 1 to 2 m into v into dv. So what we find out finally, that is half of m v2 squared minus v1 squared. So it means in any curvilinear motion, if we want to find out the work done of any particle due to the, means we can say when the force is acted on that particle, then the difference in the work done, it is nothing but the principle of kinetic energy, right? The same thing na? This is the, you all know that the kinetic energy is how much, half of mv square. So this is nothing but the change in the kinetic energy, right? So what from this equation we can say that In case of principle of work and kinetic energy, the kinetic energy is always positive regardless of its direction. Remember this thing, it is always positive, and the value is nothing but the, see, u1 to 2 means the kinetic energy position 2 minus position 1 is nothing but it shows the half of m v2 square minus v1 square, same thing. So remember one thing, kinetic energy always the positive, whatever the position of that particle is. Remember this thing always. And that equation states that the total work done by all the force which is acted on that particle as it moves from point 1 to point 2, and the corresponding change in the kinetic energy of that particle, that is also not a zero or negative, always that have some positive value. Okay. So up to this, anyone have any question? Student, is my voice audible? Yes or no? Please reply.
Yes, sir, audible.
So up to this, any question is there? If any question, you can ask. Or else I end my lecture here. Okay. Tomorrow I shall give you how to change, how means we can find out the work energy equation in case of the potential energy. Hmm. That will continue in the next class, and as well as the impulse and momentum. I think up to this there have not any if anyone have any confusion, you can ask, no issue. So shall I end here, or anyone have any query, you can ask, or shall I end? Which one you prefer? Okay. uh, then I end my lecture here for today.